Hey everyone, let's dive right into this explainer, where we're going to demystify the massive, incredibly complex world of floating production, storage, and offloading vessels, or as they're commonly called, FPSOs. If you follow deepwater energy development at all, you already know these megastructures are absolutely the linchpins of the modern offshore industry. But we're going to look at what actually goes into building one of these behemoths, and more importantly, how do you even regulate a vessel that's effectively a hybrid between a giant oil tanker and a highly explosive chemical processing plant?
So, here's our game plan for today. We'll start with the FPSO concept, then weigh conversion versus new build. Third, we'll look at the anatomy of the topsides. Fourth, we'll get into the dual regulatory burden. And finally, we'll cover the post-Piper alpha shift.
All right, Section 1, the FPSO concept. Let's get into it.
To really grasp the massive scale of these things, we have to start with the basics. An FPSO isn't just a ship, right? It's literally a permanently moored tanker and a fully functional processing plant all rolled into one single structure. Just think about the subsea ecosystem at play here. We're pulling fluids up from isolated deepwater wells through these incredibly long, flexible risers. Once that fluid finally hits the surface, it's separated, stored away in the vessel's massive cargo tanks, and then eventually offloaded directly into a shuttle tanker. It's honestly a brilliant solution for tapping into deepwater reserves where laying down a traditional subsea pipeline is simply impossible.
Moving on to Section 2, conversion versus new build. Get this, roughly 60% of the 100-plus FPSOs operating out there across the globe today actually started out as regular oil tankers. Because of that, operators face a high-stakes dilemma right on day one of any new project. They essentially have two distinct paths. Option 1 is converting an older, very large crude carrier or VLCC. Theoretically, this can save you a year or two of time and takes advantage of existing tonnage. But then you have Option 2, a purpose-built new build. As modern deepwater fields demand astonishing production capacities, we're talking up to 250,000 barrels per day, those older converted hulls can sometimes hide nasty surprises like hidden cracks or steel wastage that completely derail a project. A new build, on the other hand, gives you structural certainty tailored exactly to those massive capacities.
So how does this actually play out in the real world? Well, normally you have your standard hull, which is often built incredibly fast and efficiently in Asian shipyards. But here's the catch. Those yards typically don't build complex oil field equipment, so the raw hull has to be towed out to a specialized construction yard. There, floating cranes lift incredibly heavy, pre-assembled process modules directly onto the deck. And notice, they don't just sit on the flat deck. They're placed on these reinforced deck stools. This is a vital engineering detail. It keeps the modules elevated above the hazardous zones near the cargo tanks. And crucially, it stops the natural flexing of the hull out at sea from literally tearing the rigid process pipework apart. Pretty wild engineering, right?
Okay, Section 3, anatomy of the topsides. Think of the deck of an FPSO as this massive, extremely high-stakes 3D puzzle that's designed around strict safety parameters. You've got these huge production separators pulling gas out of the oil, plus water injection pumps that are used for enhanced oil recovery. But look at how strategically it's all laid out. The living quarters and the heli deck are almost always positioned upwind of the major hazards. You absolutely 100% must keep arriving helicopters far away from the intense heat blowing out of the gas turbine exhausts and the flare stack. Literally one misplaced piece in this puzzle, and you've created a severe operational hazard.
Now, looking at this crazy hybrid anatomy, part heavy-duty ship, part complex refinery, it actually brings us to a really fascinating pivot point in our explainer. If this massive thing is both a ship and an oil platform at the exact same time, whose rules actually govern its safety? Like, who is actually in charge out there in the deep water?
Which brings us perfectly to Section 4, the dual regulatory burden.
Because of this dual identity, the FPSO carries a massive, really complex regulatory burden. The vessel literally has to answer to completely different global authorities. And let me tell you, they don't always agree with one another. On the maritime side, because it is a flagship, the FPSO has to strictly obey the UN's International Maritime Organization. And the IMO relies on two massive pillars. First is SOLAS, which lays down the absolute non-negotiable minimums for construction standards, structural integrity, and life-saving gear. The second is MARPOL, which sets incredibly strict environmental rules to make sure these floating factories aren't polluting the oceans they work in.
Specifically, MARPOL Annex 1 is completely laser-focused on stopping marine pollution. It mandates double-hull construction and segregated ballast tanks. This means the seawater they use for stability never, ever touches the cargo oil. Plus, any water they do discharge overboard is capped at a microscopic 15 parts per million of oil. That is practically nothing. But honestly, one of the most clever engineering standards they enforce is crude oil washing. Instead of washing out the empty cargo tanks with water, which would just create massive amounts of highly toxic, oily wastewater, they blast the tanks with high-pressure crude oil itself. It dissolves all the waxy residues naturally, it's mandatory, it's highly efficient, and it is a total game changer for the environment.
And it doesn't stop there. To even stay in operation, the vessel must answer to classification societies. You can think of them as the structural guardians of the maritime world. They enforce a really rigorous 5-year survey cycle. So you've got annual surveys, just checking visible conditions, intermediate surveys at the 2.5-year mark, and then a massive special survey at year 5. We're talking underwater ROVs doing hull inspections and ultrasonic thickness gauging of the actual steel plating. The bottom line here, if you fail these surveys, you lose your certificate of class. And losing class means no insurance, no financing, and your entire multi-billion-dollar operation is completely shut down.
All right, our final stop, Section 5, the post-Piper alpha shift.
So the maritime rules handle the ship's side of the equation. But what about the highly volatile processing side? Well, that regulatory system was born from an absolute tragedy. Back in 1988, the Piper Alpha disaster in the North Sea tragically killed 167 workers. It forced a massive, painful reckoning across the entire industry. The investigation that followed, known as the Cullen Report, triggered a monumental shift in how offshore safety was handled. It made it undeniably clear that the old ways of regulating these platforms were just fundamentally broken.
See, before Piper Alpha, the offshore industry relied on something called prescriptive certification. Basically, regulators were just checking technical specs against a predefined list. It was a very dangerous check-the-box mentality. After the tragedy, they completely threw that out. They replaced it with a goal-setting safety case regime. Under this new framework, the burden is placed entirely on the operators themselves. They are forced to proactively hunt down every single major accident hazard, assess the risks on their own, and build strict controls to stop them.
So the huge buzzword to know here is ALARP, which stands for as low as reasonably practicable. The reality is, you can never eliminate risk entirely on an FPSO, but you have to legally prove you've done everything reasonably possible to minimize it. And you do this by meticulously defining and monitoring your safety-critical elements, or SCEs. These are your ultimate life-saving barriers. We're talking about your wellhead emergency shutdown valves, the fire and gas detection grids, the deluge systems, and of course, the structural integrity of the hull itself. These are the things that simply cannot fail.
But here's the catch. You don't just get to grade your own homework. To ensure absolute total compliance, the regulations demand an independent, competent person, an ICP. This is a totally separate entity from the operator. Their one and only job is to verify the performance standards of every single safety-critical element on that ship. They review the paperwork, they physically stand there and witness the testing on board. They inspect the rig, and if they find any shortfalls, they report them directly to the authorities. It is a completely rigorous, unyielding layer of independent oversight.
These vessels really are absolute marvels of human engineering, balancing on this razor's edge between two totally distinct regulatory worlds. So as we wrap up this explainer, I want you to consider this. As the world rapidly shifts its energy focus and we start seeing pure LNG, FPSOs, and all sorts of new transitional fuels hit the market, how are these astonishing megastructures and their incredibly complex rulebooks going to evolve to survive the future? It's a huge challenge the offshore industry is going to have to meet head-on. Anyway, thank you so much for joining me for this deep dive. Keep questioning, keep learning, and I'll see you in the next explainer.